Hello, and welcome to this talk on the Moon and Faversham Creek. I'm Chris Wright, and the talk was originally given to the Faversham Society AGM in September 2021. You might like to turn the lights down a little to get in the mood. At any time of the day or night, there are two tidal waves being drawn around the surface of the Earth by the gravitational pull of the Moon. They're very long, each one is wrapped halfway round the globe, and not very high, only a couple of feet, but they're moving at supersonic speed. So what's actually moving? It's not the water particles themselves, but it's the shape that's supersonic at round about 1,000 miles an hour. But since the height of each bulge is less than a meter, and since it takes many hours for the crest to pass by, we don't notice. But the oceans are divided by continental land masses that get in the way, so the bulges aren't free to keep up with the Moon. And when a bulge reaches the shoreline, it'll pile up like water sloshing about in a tray. In some places, it will thread its way through a narrow gap, and the friction can delay the tide by as much as 2 days. So the next tide we'll see in Faversham Creek might well have been created by the Moon passing overhead 2 days ago. However, it will raise a current in the creek of maybe 2 or 3 knots, depending on wind and tide conditions, with a maximum rise and fall of around 4.5 meters. This regular up and down movement of the tide comes to us from the channel, but on top of the regular tide, we can get surges caused by bad weather in the North Sea, and these are the ones that cause flooding problems in the UK. So in this picture, we see the rise and fall of the tide in Faversham, and you can see it's not entirely regular. The up and down movement grows and declines over the period of a lunar month. And this is because there are two influences at work, not just the Moon, but the Sun as well, and the two waves are not quite in sync. And there's an analogy here with a musical instrument whose different parts can vibrate at different frequencies, which, when added together, produce a characteristic wave pattern which gives the instrument its particular timbre. And I like to think of Faversham Creek as having a particular timbre of its own, which is shaped by not just the Moon and the Sun, but the shape of the creek itself. So the question we're looking at is why do the tides matter to Faversham? Because in medieval times, they created, in a sense, the foundations of the town's prosperity by scouring out the creek and widening it and deepening it, which enabled ships to go up and down and gain access to the hinterland. And this matters because in medieval times, there wasn't a good road network. Travel overland was difficult and expensive. Whereas if you were creating agricultural produce near to the foreshore, you could load it onto ships and sail up and down the Thames estuary and trade with towns like London. Creeks in the north, along the North Kent coast, enabled access to more land, and that made the area potentially more prosperous. Now, a few years ago, I became interested in why the wharves in Faversham, where ships were loaded in medieval times, were mostly on the eastern bank. Was there a particular reason? And that means we have to think about how a heavy load might be moved from a point in the neighbourhood of Faversham to the nearest point on the waterfront. And it's the same problem that you have when light moves from a dense substance like glass to a less dense one like air. It doesn't follow the shortest route. The quickest route involves a change in the angle. It refracts at the boundary between the two. And the two angles in this diagram, θ1 and θ2, are related by a simple mathematical law known as Snell's law. And here we have a special case, because when goods are loaded onto a ship, they travel away towards London parallel to the shore. So the angle θ2 is 90 degrees. And that makes it a lot easier to do the arithmetic. Let's assume that travel over water is roughly twice the speed of travel over land. Remember that travel over land was very difficult in medieval times. And if we make that assumption, then the best strategy, if you want to send goods to London, is to approach the foreshore at an angle of around 30 degrees. And of course, the angle will never be exactly 30 degrees, because the topography will vary and other factors will get in the way. But nevertheless, there'll be a general bias or a tendency for goods to move at an angle towards the west. And this means that they will pile up on the eastern side of Faversham Creek in larger quantities than they do on the west. There's a big difference in the two catchment areas shown in green. In fact, there's an even larger catchment area to the south, where the quickest or the cheapest route to London involves goods converging on the head of the creek over quite a wide area, shown by the heavy white line. But there's still a general bias on the eastern side. Well, that might seem to explain why the wharves in Faversham are on the eastern bank of the creek, but it's all too simple, isn't it? I mean, there must be lots of other things going on. So let's have a look at neighbouring towns and tributaries along the North Kent coast. And what we find is, historically, these towns are all centred in areas to the east of their respective rivers and creeks. North Kent ports, if you look at them from the point of view of a ship coming into the port from the River Thames, are mostly left-handed. There seems to be a pattern emerging here. So let's have a look at the other side of the Thames, at the towns and rivers in Essex. And here again, we see that the ports, the towns, are mostly on the eastern side of their respective rivers and creeks. I have to say that I don't actually know where the original wharves grew up or evolved during the Middle Ages, but we can look at an ordnance survey map and we can find out where the parish church is, we can find out where the town centre seems to be, and in almost every case it does turn out to be quite definitely on the eastern side. So more questions now come crowding in. How can you make a narrow creek into an effective port and sail up and down it under the action of the wind alone? Well, there are lots of ways of doing it. This is just one of them, a technique called drudging, where the ship is dragged in by the tide and you actually go in backwards using the weight to keep the stern first, which allows you to steer against the pull of the water. There are other methods of doing it. They're not easy, but they are easier than carrying 50, 70 tons of stuff in carts drawn by horses across a muddy field. And in some ways, a narrow creek has an advantage, because the fact that it's a narrow tube forces the water to move quite quickly from the head of the creek to the mouth when it's discharging at low tide, compared with a wide bay where when the water goes out, it moves relatively slowly. And a basin at the head of the creek adds to the flow and helps to increase the rate of scour. In fact, in some ways, in medieval times, you could see a creek as a local motorway, a system of high-speed transport. And that's why 2 or 3 generations ago, Faversham Creek was celebrated by local people as part of the town's infrastructure, part of its economic prosperity. Well, today we're at an exciting point where much of the industry has gone and the detritus has been cleared away to reveal a very attractive townscape. The waterfront in a town can be amongst its most attractive features, and in Faversham, the potential is enormous. It can be a very valuable educational and recreational resource. So if you've got this far, thank you for listening. I hope you've enjoyed it. And when you go to sleep tonight, remember that the tide is coming. And in this uncertain world, it's something that we in Faversham can always rely on.